we want to now make the plot that we're going to create. So we're going to make subplots. We're going to name it figure, so when we're able to call it, we can just write down figure and we just call it. And what else we're going to do is we're going to do figure dot add trace. We are going to do scatter 3D. Then we're going to make a 3D plot, and we're going to be naming the add traces it to it, and we're going to be naming the axis. For the x-axis, the Reynolds number, the y-axis, the Schmidt number, and for the z-axis, the Sherwood number. And we want the mode to be markers. We also want the marker color to be the Sherwood number, and we also want the Sherwood number to change with respect to the Reynolds and the Schmidt number. So as the Sherwood number changes, it will change color, and we want the size of those markers size to be about 3. It says go scatter. I think it's go dot scatter. I think so. Go dot. Oh, looks good. So we have our plots, and the Sherwood number as Reynolds, as it changes with respect to the Sherwood, the Schmidt, and the Reynolds, is changing. So now we want to create a mesh grid. We want some vertical and horizontal lines. Okay. Let's create that right now. Okay. Okay. So we want to make the Schmidt grid and the Reynolds grid. We're going to add a mesh grid to it. np.linspace. So we want evenly spaced lines for the Schmidt and the Reynolds number. So we know that the Schmidt number, the lower bounds for that is 0.6, 2.5, and we want about 20 points. And we're going to do the same thing for the Reynolds number. So np.linspace, we know that the lower bound for the Reynolds number is 2e to the 3, 35e to the 3, and we know we want 20 points, and it ran correctly. Beautiful. So now we want to create the Sherwood grid, and we're going to base this off the Sherwood-Gilligan correlation that we defined above, and we're going to use that variable we created above, which was u. We're going to put the first element of the equation. We're going to multiply it by the Reynolds number multiplied by the second element of the array 1 multiplied by the Schmidt number grid Reynolds, that's supposed to be grid, multiplied by the third element of the array. Okay, everything looks good. Now we want to make some vertical lines and horizontal lines that go with the grid. We want to pair the grids together. So what we're going to do is we're going to create 3 random variables. And we're gonna go, and to be able to zip these variables together, we want to create the zip function. scgrid regrid shgrid and now we're going to name these variables. Go.scatter 3D I RE ISC. We want to pair the grids together, so we're going to be creating a for function. sh. We want them to be horizontal lines, horizontal and vertical lines. We're going to make the line color gray, spelled gray wrong. So we want a mesh grid. We want it to be varied with the Sherwood number, and we want them to be paired together. So we need to we want them to be perpendicular to each other. So we're going to copy. Let's make sure this runs good.
Plotly.graph objects, go scatter 3D, add figure dot add trace oh, I didn't even put x equals y equals. I won't even know what to do if I never did that. I'm gonna make sure it all runs good. Now we want them to be perpendicular to each other, the lines. So we're going to copy and paste all the code, and we're gonna switch the grids around. So this, we're gonna change this around, the Raynaud and the Schmidt grid around, and I think that's all we need to change. And now we're gonna look at the figure. Oh, we made our mesh grid in the vertical lines, and the horizontal lines are showing. You can see how it changes according to the Sherwood number. Let's clean this up and rename all the axes, take out the show legend, make it a little cleaner. So what we're gonna do is do figure.update layout. We want the width of it to be, so we see everything better. Let's just say 800. We want the height to be 800. And now we're going to rename all the axis titles. Maybe that's Raynaud, Y equals Schmidt, Z is the Sherwood. Actually, that's not how you rename it. You have to do x-axis title. And that's going to be Raynaud. I'm going to copy and paste it to make it a little easier on myself. Axis. We're going to change the y-axis to the Schmidt number. We're going to change the z-axis to the Sherwood number. And we want the show legend to equal false. says, oh, I put negative 800. It's going so fast. Okay. Here's our graph now. Or plot, 3D plot. Scroll this up. So this is the mesh grid for the Sherwood, Raynaud, and the Schmidt correlation for water going down a circular duct. Thank you very much for watching.